Hi, this is a review of factoring algebraic expressions, and I'm just going to do a quick summary of the different ways we can do that and give one quick illustration of each. I'll include links down in the comments below, so if you like, you can review one particular style of factoring in a bit more detail and see some of the curveballs that can be thrown at you. But in general, when we're factoring an algebraic expression, there are four sort of different tools that we have in our toolkit. The first one is common factoring, and the rule of thumb is if we can common factor an expression, even if we can do other forms of factoring, we always want a common factor first. So if you can common factor, do, and I'll go over an example of what that looks like. And then depending if we have a trinomial or an expression with three terms, or a binomial, an expression with two terms, we have three other options. So trinomial factoring, if there's no number in front of the x squared term, or it's of the form x squared plus bx plus c, there's a fairly simple trinomial factoring. If there is a number in front of the x squared, like 3x squared plus 2x minus 7, then we have to do factoring by decomposition, which has one or two more steps. And finally, there's the difference of squares. If we have a binomial where it's two perfect squares and you're subtracting them, there's a negative sign between them, then we can do a difference of squares. So let's just do a quick example of each. So example number one, common factoring. So common factoring, in an expression that we want to common factor, what we're looking for is the largest common factor that goes into each term. And what that means is the biggest number that divides evenly into all the coefficients, and the minimum number of each variable present. So if we've got x's, how many x's minimum does each term have? If we've also got y's, how many y's minimum does each term have, etc. So an example would be, let's say we had 9x squared y plus 6xy squared minus 3 x squared y squared. So in this case, what I do is first I look for what's the largest common factor of all the coefficients, which in this case is 3. So I take a 3 out front, and that means I'm going to divide each of the terms by 3 in the brackets. But before I get into that, I'm also going to look at what's the minimum number of each variable present. So the first term has 2 x's, the second term only has 1, the third term has 2 x's again. So the minimum number is 1x minimum in each term. And then I do the same with the y. There is 1 y minimum in every term because of the 9x squared y. So that's my common factor. So to find out what goes in the brackets, remember I divide each term individually by my common factor. So 9 divided by 3 is 3. X squared divided by x, or in other words, I had 2 x's, I took 1 out, I'm left with 1. Y divided by y, or in other words, I had 1 y, I took it out, I'm left with no extra y's. Move on to the next term. So that's a plus, so a plus goes here. 6 divided by 3 is 2. I had 1x, I took 1 out, I've got no x's left. I had 2 y's, I took 1 out, I have 1 y left. And finally, the last term, 3 divided by 3. First of all, it's a negative, so that negative comes down. 3 divided by 3 is 1. I don't need to write the 1, but I will this time. And I had 2 x's, I took 1 out, I've got 1 left. Had 2 y's, took 1 out, I got 1 left. Awesome. Next. So next, we are going to move into trinomial factoring. So trinomial factoring, if there's no coefficient in front of the x squared, it's a little easier. So for example, if we have x squared plus 7x plus 12, and I want to factor this. In this case, I like to do it by creating a chart. It helps me just sort of think through finding the right numbers. And I remember that my two numbers that are going to be in my binomials in my factored form have to add up to 7 and multiply to 7 or to 12. So the sum is 7, the product is 12. And I think about it and I see, okay, what two numbers add up to 7 and multiply to 12? And they are 3 and 4. If in doubt, I can always write out the factors of 12, like 1 times 12, 2 times 6, 3 times 4, and then see which one adds up to 7, and I say, oh, it's the 3 times 4. So if you get stuck figuring out the two numbers that work, take the extra few seconds and write out the list of possibilities. Once I have these two numbers, trinomial factoring with no coefficient is very straightforward. This just equals, we make two sets of brackets. We put our x in the lead of each bracket, and then these two numbers, including what their sign is, go in the brackets with them. So it's plus 3 and plus 4. So the last trinomial factoring we're going to do before we get into difference of squares is decomposition. So factoring by decomposition involves a couple more steps. So let's take a look at it. So for example, if we have 2x squared plus 7x plus 6. So I picked these numbers on purpose so it relates to our last example. In this case, when we do our sum and product chart, our sum is still the 7, the coefficient of the x term is our sum. But our product is 2 times 6, which is actually the same as before when I had x squared plus 7x plus 12. That x squared, since there's nothing in front of the x squared, it's automatically a 1. And my product is 1 times 12. But I don't do that when it's in that form. I know it's just the last number because the first number is 1. But the truth is, in every case, we multiply the coefficient of the x squared times the constant term, and that gives us our product. So in this case, again, it's 12, which means our numbers are 3 and 4. So in this case, we call it decomposition because we have to decompose this middle 7x term. Now, before I do, I often like to look ahead and say, which number goes better with the 2 and which number goes better with the 6 to common factor in a minute in terms of what order do I need to write these in. If I don't get the order right, I can still get the answer right. Like it might be just a little bit trickier, but I'll still get there. But I can save myself a little bit of heartache if I write this in this order. So 2x squared. So I got to decompose that 7 into 3 plus 4. So that I'm going to write the 4x first because the 4 goes nicely with the 2. And then the plus 3x second. And well, the 3 goes nicely with the 6. So I haven't changed the expression. I've just split up that 7x into 4x and 3x. And now I look at the first two terms and I common factor the first two terms. And I say, okay, 2 goes into both the numbers and there's at least one x in each. So my first bracket is x plus 2. And then over here, it's 3. So I go plus 3. And when I common factor the 3, I get x plus 2. And now I always smile when at this stage I see the exact same thing in both brackets. That makes me feel good because I know I'm on the right track. So now I common factor this and this, where my common factor is the bracket. What that looks like is I go x plus 2. And then multiplied by the 2x plus 3. So the leftover junk goes in the second bracket, 2x plus 3. So that's factoring by decomposition. And now we will move on to difference of squares. So a difference of squares, this will always be a binomial, and it'll always be in the form where it's something subtracts something. And if I have to factor and it's something subtracts something else, it's most likely a difference of squares, although check for common factoring first. And it should be in a form where you've got a perfect squared. So for example, 4x squared minus 9y squared. So in this case, like 4x squared, the sort of off to the side or just in my mind's eye, I think of that as 2x squared. Subtract 9y squared, I think of that as 3y squared. So now I have a difference of squared because I have this squared minus that squared. So it's a difference because of the minus, and these are both perfect squares. So the rule is it's the first item, 2x, plus the second item, 3y, times the first item, 2x, minus the second item, 3y. And if we take the time and expand this using FOIL, we'll see that we ended up right back where we started at 4x squared minus 9y squared. So this is, in fact, a correct way to factor a difference of squares. So I hope that's useful. That's a quick summary. Again, look below in the comments for more details about each form of factoring, and I'll do some, include some of the curveballs that can be thrown in each type.